Hi, everyone. Hope everyone's enjoying a wonderful day at the Boston Convention Center. And thank you so much for joining us at Inforce 2022. So welcome to NIS205, building a scalable and secure global network infrastructure on AWS. My name is Gene Ting, a Principal Solutions Architect in Amazon Web Services. And today with me, three folks that also went on a similar journey. David Hoffman, Associate Director of Cloud Technology at Sony. James Webb, SVP of Security and Technology at Avalon Healthcare. And Eric Ellis, Director of Enterprise Cloud Technology at Avalon Healthcare as well. So in this session today, we'll be talking about how you need to think about how to build a hybrid global network infrastructure on AWS and how to secure it as well. So planning out a global hybrid network on AWS starts with mapping out the locations, the resources that you need to consider in order to understand your networking and security requirements. You need to know where your data centers are, what kind of branch offices you need to support, the type of corporate offices and locations of these offices as well, and the connectivity that's available to each of those places. You need to understand the application servers, the type of network devices that you need to also consider to support these applications, the type of storage, and also the application objects that's involved in your systems as well. And most importantly, you should understand where your users are, whether it's offsite or within the corporate network and the connectivity options available to them. You start mapping out those resources to the various constructs that's available to you at AWS. So starting with the VPC that helps you contain your application to share resources, helps you understand how you're going to place in other connectivity options through either workspaces as well. How connectivity to data centers to our regions through Direct Connect works, and how they can be encrypted with MACsec, or to other branch offices over options such as site-to-site VPN, or for your users with client VPN as well, which will encapsulate your traffic and keep it private over the public internet. You look at how Transit Gateway works and how they bring those pieces all together in a simple and consistent network topology at each region, and how Transit Gateway also helps you bridge across multiple regions around the world and create a global network mesh. And you can also look at other services such as Private Link that helps you connect to our services privately, or to other service providers within the region, or even providing your own services to other customers within that region in a simple and secure manner. Each of those constructs allows you to operate on the resources provided within AWS in an authorized manner due to use of IAM. Through IAM access policies, you could provide fine-grained control to your network operations team so that they can work on the infrastructure in a secure manner. In addition, you could view what kind of operations is happening on your infrastructure through CloudTrail logs. So CloudTrail logs allows you the ability to audit the activities that's happening on your infrastructure, or feed them to other threat detection systems such as GuardDuty, so you could detect whether or not there's malicious behavior or malicious activities or anomalous behavior that's happening within your infrastructure. You could utilize services such as Inspector to look at servers to see if there's unusual ports being opened that you're not aware of, or understand the reachability of those resources in a VPC with the Network Reachability Analyzer. The findings that's being gathered from GuardDuty and Inspector can be fed through Security Hub, a single point of view for your security operations. And finally, to lock down and secure the network, you also need to consider other types of security features such as those that's offered in the VPC, such as security groups and NACLs, as well as apply firewall services such as Web Application Firewall or Network Firewall as well. So AWS Network Firewall is a fully managed service that offers network protection on your infrastructure quickly and scales up and down based on the demands that's being applied on your network infrastructure. You could set up rules or apply managed rules quickly and establish them within the high capacity rules engine as well. You can manage those rule groups centrally and view the traffic that's happening on your network firewall in real time. Core to the network firewall features is packet filtering. We could establish stateless rules so that you could create large IP block or allow lists, or stateful rules for more sophisticated threat detection and prevention as well. So to perform activities such as FQDN filtering, or looking at the packets more closely for signatures related to known threats. You could view the activities in real time through CloudWatch, where you can see the total volume of traffic that's running through your network firewall, see how much has been accepted or dropped as well. You get full network flow log visibility that's happening through the firewall as well, or you can also collect alerts in real time based on the rules that you establish there as well. You can send the logs to either S3, to CloudWatch logs, or to Kinesis Firehose for real-time analysis. You can manage those rule groups through Firewall Manager at each region, so you could consistently deploy those rules across all your firewall instances. You can also deploy the rules quickly through CloudFormation or Terraform templates directly to the firewall or to Firewall Manager as well. And you could either subscribe to manage rule groups or share your own rule groups through Resource Access Manager. So there are several ways you could deploy network firewall, and we have guidance through our blogs and our documentation. Two ways that you could actually consider deploying firewall is, one, you could actually create one in the VPCs to accept traffic from all the attachments at your transit gateway for inspection at a central VPC before deciding whether or not to send them on to their final destination. If centralizing inspection isn't appropriate for some of your use cases, you can still decide to deploy the firewall individually at each application VPC and have the inspection done locally there. You can combine these two models as you see fit based on your governance model on the infrastructure. So you could create your own rules or use managed rules as appropriate and as you see fit. You could start with stateless rules that's prioritized for speed. It quickly matches based on the 5-tuple match criteria. And you could drop or pass the traffic based on the match. Or if nothing matches, you can send it down to the stateful rules engine for further analysis. The stateful rules engine is there, so you could handle more complex inspection based on whether or not it's on malicious activity as such. You can consider other types of other contents to the packet, such as the direction of the traffic, or whether or not it's based on a connected session as well. You either pass the packet through, you drop it, and optionally, you could alert it to send it down to CloudWatch logs. In addition, if you're not as experienced on creating rules, you could also consider using some of our managed domain lists and managed threat signatures as well. With managed domain lists, you could block your traffic based on whether or not the traffic is destined towards domains that has low reputation, or those that has been linked to malware botnet attacks in the past based on our threat intelligence. You can also either use our threat signature rules directly, or you can copy them and modify as you see fit and apply it to rule policy, your rule groups as well. One excellent example of how to use these rules to establish protection quickly is that you could take them mitigate the log4shell attack. And we have a lot of documentation on how you can do that yourself in your infrastructure. And finally, you could also subscribe to rule groups that's provided by other AWS partners, such as Palo Alto or Trend Micro, and availability to those are based on your relationship to those vendors as well. So with that, I'm going to hand the mic off to David here, who's going to talk about Sony's journey on building a global network infrastructure and how they applied some of the concepts we talked about here so far.
Thank you very much, Gene. I'm David Hoffman. I am the Associate Director for Global Cloud Services at Sony. I will start by saying the fact that I don't speak for all of Sony. Sony's a very large company, and we have a lot of different groups, everything from PlayStation to BioWare to now we're into cars. You name it, Sony is doing new things. But my job is to coordinate a lot of stuff between a lot of different operating companies. And one of the problems we faced was how do we connect a number of different AWS accounts, particularly in situations where new companies are coming in, we needed to add more. Before I do anything else though, I am also going to take a moment to point out the nice little dragon here. This is Fred. He is my son's dragon who I take all over the world. So that is why I have a dragon on the stage, because I take my son's pet dragon with me everywhere. So we're going to talk about the why, some important steps that I would recommend you all consider as we're doing this, and then we're going to look at some of the design docs. And then the wonderful folks that are coming in after me are going to go into a little more detail on their design docs, which is going to be really interesting. Let's talk about the whys. So in early 2019, when we started doing this, we did not have the Cloud WAN. There are some things that have prevented us from moving to Cloud WAN at this point, but if you are looking at this journey at the start, I would also recommend that you spend some time talking to AWS resources about the Cloud WAN. However, if you decide to follow this approach, which has some benefits to it, keep in mind that there's certainly some situations that you want to take into account. This helps with scalability. Our system is set up so it doesn't matter how many accounts we're going to add to the system, we can continue adding more VPCs, more capability things. You need to consider your IP conflicts. You want to have a solid strategy to avoid your IP conflicts. That was one of the biggest problems we ran into, because as we found developers had spun up VPCs, particularly when there was less governance early in earlier years, a lot of people were using the same VPC ranges. This also reduced duplication resources. If you have a large account and you have a large number of VPCs, take a look at how much you're spending on your NAT gateways. And I think a lot of you guys may be surprised at how much it is, because it quickly adds up. And if you have, say, 300 accounts and you're having a NAT gateway in multiple regions, that cost can add up quickly. So it's a good thing to get them to lower the cost, which can get you to buy in, get your project to be able to do something like this. This also helps with common methodologies. Once you start doing IP routing and you're doing your transit gateways, you're doing your egress monitoring, it creates the basis that you can create other standards later. Troubleshooting is the last one. Before we started doing this, the number of times I got a call in the middle of the night because somebody couldn't get access to some server somewhere, and the first thing I'd have to do is go in and try to look at their VPC and figure out what they had done and how they had set up their route rules and all that kind of stuff. Really becomes a nightmare. And then you get into the conversation of, well, are you whitelisted with whatever person you're trying to talk to? How do we track that down? This simplifies a lot of that process. Important first step. I mentioned this a little earlier. I will bring it up again because it is by far the thing that I can stress the most about, is think about your IP strategy. Are you going to go public IPs? Are you going to go private IPs? Are you going to automate your IPs? What ranges you're going to apply. What we did is we decided that every AWS region at the beginning, we were going to assign an IP range to. And that every group has it, even if we didn't have workloads in it. So for example, if we were not going to use like the South Africa region, didn't matter. We still assigned an IP, that way we can expand into it later. The other thing we found consistently is that developers will want as many IPs as you're willing to get. As I mentioned earlier, a lot of our developers ended up requiring the same things. A third of our accounts were using the same IP ranges, and 80% of them had assigned themselves a /16, which is a ridiculous number. On average, we find that most developers only use about 40% of the IP ranges they request. So what we did is we set a simple policy. The smallest you could get was a /28 because that's AWS's minimum, and the biggest you could get was a /23. If you wanted bigger than a /23, you had to go through a process to justify why you needed it. And it was amazing, when I put that policy in place, the request for bigger than /23 dropped out. From I was getting 20 or 30 of them per month to now I get about one every other month because they didn't want to go through the process and they actually didn't need it. And even when we go back and audit today, we find that they're still only using about 40% of the IP space that they generally ask for. There is a lot of different network features that you can go ahead and look at. Make sure that you're using the sitter block grow. So if your group wants to assign an IP and they only need maybe 128 IPs and they're like, oh, but in the future we may add container thing. That's fine. Request the 120 IPs today. When you need to add those additional IPs, we add a second sitter block to your VPC and we move on. It's not a big problem. Also consider using Route 53 hosted zones, and there's a little bit about that that I will provide on the slide later, because you need to make sure you handle the authorization properly, but it's a really good useful resource for when you're trying to coordinate stuff on the back end between different things. This is a very high-level overview of some of the networking capabilities of how you would build out this. In this situation, I'm giving an example of just 3 regions. Right now in the network I've got in over 13 different regions that we're running it in, but this simplifies it down a little bit. In this approach, we're looking at 2 different direct connects coming in from 2 different regions. Both direct connects are going directly into the transit gateway. From there, you're going out to this individual VPCs that you're doing. We set it up so we have an Egress VPC, we have a sample application, and we have a shared services application. We've done that in region 1, and we've done that in region 3. In region 2, we have no direct connect. So any traffic coming on premise is going to come in through the transit gateway and go across. Something to keep in mind when you're setting this up is you can set up transit gateway as a true mesh thing. Every region touches every other region, so that way there is no daisy chain bottleneck type situation. I will also note that when you're starting to think about how you're building this out, there's a couple things to keep track of. Traffic between different locations across the transit gateway travel at 50 gigabytes per second. However, if you decide you need to use VPNs, either come back on premise or to third-party applications, or maybe you have a facility somewhere else that you need to go to, the VPNs connected to transit gateway have a 1.25, so you may have to daisy chain several VPNs if you're going to do that. There you go. The next thing I want to point out to you guys as you're thinking about this, and this was a problem we ran into a lot, and it took me a while to get my brain around, is making sure you get the route tables right. Spend the time, think about it, get your route tables right, because otherwise you're going to either end up with a lot of route tables or you're going to end up with a bunch of route tables that don't work as well. The key point to always think about whenever you're working with transit gateway or the NAT VPCs or egress stuff is you are attaching it to the point where the traffic is coming from and deciding with that table where the traffic is going to. It is not ever referencing the return traffic. It's only going one way down the pipe. So in this situation, I have a VPC that is sending information to egress. I have one that's going to another region, and I have 2 going applications. Now, the VPC egress is going to have a separate route table attached to it to send traffic back. But VPC 1, VPC 2 both can use the same route table and send the traffic everywhere solved. So by these 2 systems, I now have solved it for 4 different VPC situations. So let's talk a little bit about inspection and when we start getting inspection. This is going to be your classic east-west, north-south type inspection. It's a standalone inspection type capability. I put the route tables up here to show again the example of how the route tables work, which I will not include in some of the later slides. But as you can see, so for subnet A, we have the traffic and it's pointing at the firewall endpoint in subnet zone A's firewall subnet. And by the same token, for the transit subnet B for ingress is going into the firewall. So it's going to come into that first subnet. You need to direct it to the endpoint of whatever you're doing. This is the same technology. If you guys are using NAT gateways or something like that, it works the same. And then the key thing is when you have the return traffic, that subnets need to make sure that you're sending it back to the transit gateway. 90% of the problems when I find when we set up new systems was the fact that the traffic was being rerouted back to the first subnet, and that will break your flow. You need to make sure you're sending it back out to the transit gateway. Otherwise, it'll try to hop through, and the subnets do not support that. Egress VPC. So this is a very basic egress VPC. All you were doing is having traffic come in through the transit gateway. The transit gateway subnet basically takes that traffic and says, send it to the endpoint IP. You send it to the endpoint IP, it goes out. When it comes back in, you're going to do the same thing we just talked about. You need to make sure that the traffic coming back into the NAT gateway is going back to the transit gateway, and just make sure that you're assigning things properly. Now we get a little bit more complicated. This is one of the diagrams of one of the systems that we've used several times that's really useful. We're basically combining up the two approaches to reduce the load. Traffic comes in, it goes to the firewall layer, the firewall process it. You send this out through AWS's firewall endpoint, it processes the data, it comes back. When it comes back, it makes a decision at that point. If it is 0.0.0 traffic, it's going to go pass it then further on into the NAT gateway, and it's going to go out into the world. And then the traffic's going to come back to the NAT gateway and immediately go to the trans gateway. If it is not 0.0, if we're doing, say, east-west traffic in this situation, at that point it will detect those IPs and it'll send directly to the trans gateway coming directly out of the firewall. The reason we like this approach is it combines up the things. It saves a little cost on the VPC management stuff. I will tell you that some of the security folks always worry about the fact that we'll accidentally send traffic out through the internet. But again, that's just a matter of making sure your route tables are secure, setting up some good config rules that if anyone goes messes with your route rules, and setting up your network firewall or your network ACLs properly, you should not have any issues with that. Now, why would you want to do this? These is a couple sample applications that I threw up on the screen of different situationals that you're going to have like this. So the first one is a simple internet-facing application, your general website type situation. Customer comes in from the internet, they hit the load balancer sends traffic to the application makes a call to the database responds back to the application sends the data back to the load balancer and goes back to the internet. Regular flow. The important thing is that first one doesn't have a NAT gateway. So if that application server needs to go get a new patch or needs to make an API call or you're running an SMS function on or anything like that, instead of going out through a NAT gateway and that internet gateway, it's going to send that traffic instead to the transit gateway, follow through your normal process, whether it's going to go access VPC endpoints or go out through an Egress VPC that you're monitoring. And the nice approach about that is you're, again, removing NAT gateways, so you're reducing costs there, but you're also centralizing where your firewalls are being managed for egress. So you have central points for egress that you can easily whitelist, and you have centralized locations that you can easily monitor your thing. The second one is an internally facing application, such as if you have a direct connect that you're coming up through, same basic approach. You're coming in from the transit gateway in this situation, you hit the load balancer application database, and back. In this situation, if the application servers need to go out, get a patch, get something, an update, it will then make, again, that call across the transit gateway, either using the egress that you've set up on your transit gateway, or else it'll set up, a VPC endpoints. The last one that I've done here is if you don't have a transit gateway approach, if you want to use the firewall system in a standalone environment, maybe you have an application that for whatever reason you need to segment from other things, or you've got a situation where somebody has brought an account in that was external to your setup and you're bringing it in. What you can easily do is modify that system and drop a subnet in between it and create the system. By adding that firewall subnet, all you have to do is then change the route tables and the network ACLs so that all the traffic going from the application layer goes through the firewall and all the load balancer layer goes also through the firewall. So what you're doing is passing through and passing back on each way. It's a very easy way to make a quick, secure thing. We used this several times when we were getting going to be able to do testing and stuff like that, and also to get things where they weren't ready to onboard to the trans gateway because of IP conflicts. This is a way to start getting their traffic being monitored and approached to. I want to talk a little bit about how we do our firewall updates. There is a whole mess load of different options out there to do it, but this is the way we do it. We have two different interfaces that come in. So we have our rules that we create, and then we have a set of rules that come in from our security group that are things like which domains to block, what bad actors are out there, those things. Both of those get uploaded into our GitLab environment. The GitLab environment processes those rules, creates a simple CDK file that updates our rule file. We run through our GitLab environment to process all of our data, and then we deploy it out to all 3 of the regions in this example. You can also use Firewall Manager to do the same approach. Right now we are deploying out to individual regions because we haven't finalized how we're doing our AWS Firewall Manager at the organizational level approach to do this, and because in some regions we have a little bit of differential in some policies that we have to make. However, it gives a very common approach to be able to do so. In doing the Cicada rules, it works exactly the same approach. You push it through, it does. If you're using managed firewalls, Trend Micro, Palo Alto, AWS managed firewalls, there's a dozen of other vendors out there that provide those kind of firewall rules. You can cross-mix those 2 sets of firewall rules. So you can have your own custom ones, you can have a vendor-managed one, and you can have an AWS. The only thing to keep in mind when you start getting into that is the limits that you have on how many rules you can apply in. The next area I wanted to talk a little bit about was centralized VPC endpoints. This is something near and dear to my heart. It's something that I've been working on for a lot over the last 6 months in particular. And this is because A, it reduces your costs. You're not making calls out across the internet. You're reducing your security layer of what it is. Most endpoints are fairly inexpensive. The S3 endpoint is the only one that is kind of a balancing game of how much the cost is. And it allows you to very easily set up policies to monitor how your traffic is going. The endpoint policy system is really good for making sure that you can set it by organization. That way somebody who manages to get a VPN connection or somehow accesses your system doesn't necessarily be able to use your system, pass traffic through to your endpoints and do other things on you. I don't ever recommend that you set your access control based upon your VPC endpoints, but we have had situations where that happens. This somewhat helps eliminate that problems. However, the approach is very similar to what we've talked about already. What you're going to do is have the transit gateway traffic come in, it hits the endpoint is going to process the data, it's going to send out S3, Amazon, there's dozens and dozens of endpoints at this point, and then it's going to transfer the data back. The thing that I want to cover real quick on DNS for endpoints, when you're looking at doing endpoints, you can do one of 2 approaches. You can either use the endpoint name, and most CLIs and most tools will use the endpoint name to process it, or you can use a local hosted zone to replace the endpoint name. If you use a local hosted zone, and honestly I recommend it because it makes it easier for your developers to remember it, you don't have to have a cheat sheet of what your different endpoints are. The thing that you got to remember is it's a 2-step authorization process. You are authorizing the VPC to be able to use that hosted zone, and then they have to accept it and then add it to the thing. AWS has a recommendation that once the acceptances happen, that you go ahead and remove the authorization. The authorization is just for the attachment. You can remove the authorization afterwards, and the association is still there, it still works fine. But there is a limit to how many different authorizations you can have outstanding there, and that's the reason that they recommend that you remove it. Some final thoughts. I'm a strong believer in automation. If you can automate it, always the best thing. I've policy with my team that if I have to do something more than twice, I want somebody to work on figuring out how we're going to automate that process. Whether you're starting new or whether you're converting over existing accounts, think about your IP strategy. You will struggle the most with that, particularly if you have an existing system, but it is really the biggest building block that I can recommend. Where possible, use common routing tables. Nothing is harder than finding out that you have 100 different routing tables because you've built out a special snowflake for every route. It becomes a nightmare when you're trying to do auditing and stuff like that. Also give yourself a lot of space when you're building out your firewall rules. The first couple times we did our firewall rules, we basically just sized them based upon how big we thought we were going to be, and every time we found out that we needed more. So be aggressive. If you say, I am going to need 500 entries, double it, send it at 1,000. It will help you in the long run because otherwise you're going to have to tear down the firewall rule and put it back into place. Also, really consider about how you're going to do your flow. Flow logs for Firewall comes in 2 flavors. It's alert or all traffic. Both have values, but you're having a cost of wherever you're going to stick that in S3. I'm going to just put this up here. I'd like to say thank you to a couple people. James Chung, who is part of my team, Jean Ting, who is just up here, who is my solution architect, Tim Shea, who is folk that inspired me to do a lot of this, Jeremy Tan and Asaf, who are both part of our network group that helped us a lot. And I'm going to leave this link up here as I request the wonderful Avalon folks to come up here and take over the stage for me. These are a couple links that may help you out.
Thank you, David. David gave us a lot of technical expertise in his presentation. I think it was well organized, so thank you. What we're going to actually talk about is probably extreme security and extreme growth, and how AWS and the Palo Alto Networks is helping us get past some of the challenges that we're having implementing both those. So hopefully you'll find some value in our story. First off, I am Jesse Webb, the Security and Technology Officer for Avalon Healthcare Solutions. I've been in IT for over 20 years, information security for 12, and we've been operating in the Amazon environment for over 8 years. Avalon, world's first lab insights company. That is, we actually is really a laboratory benefit management company that has grown into a lab insights company. We were founded in 2013 as a PowerPoint presentation, and we had to convince health plans to give us 3 years worth of claim data to analyze and take that PowerPoint presentation and turn it into a company. So we had to have security built in from the ground up, day one, and we had to make sure that we had the confidence of the health plans to move forward to develop out Avalon. So what is Lab Insights? Really, it's delivering the right test, collecting the right data, taking that and getting the right intel, machine learning, and delivering the right care from that information. Some of these metrics, let's say a medium-sized health plan that is delivering benefits to their patients will spend $1 billion in lab spend. A 10% savings, that's $100 million in savings that Avalon is delivering for a medium-sized health plan. Several other metrics so you can see the size of the company, but probably what's most important out of this slide is that we're housing 33 million members' patient data. Our customers are health plans, so you can see why we take security very seriously. All of you guys are probably security professionals and have a lot of context to it, but part of this is just telling you why we have done some of the things that we've done. Taking that zero trust, negative security model very seriously. We've built it into our networks, built it into our design. We're hyper-segmented across multiple VPCs, multiple organizational units. We've built it into our design throughout, even in the VPCs. Nothing really works until we say it works. And it has to be opened and designed to operate, and it operates only in the fashion that we want it to. HIPAA's minimum security, minimum necessary rule. This is a context that we've taken even through our design and our systems, how we harden our equipment, harden our servers, harden our processes. We try and keep only the data that we need, but as you can see, it's already scaled up to 33 million members. But we try and only keep exactly what we need to deliver the service. The defense in depth aspect. We take this pretty seriously. We assume that something is going to fail, that something is going to be breached. We could have a supply chain failure of a trusted application. We're going to ask that question of what's next? Where is it going next? What is going to be the next step? How can we isolate that workflow process so that it doesn't go any further than where it's landed? That defense in depth, we're thinking about the layered security and the aspects that go along with preventing it from becoming a shared fate failure across the entire design. The last thing, probably banging the drum with this crowd, but building it into the culture. I had the good fortune of starting this company as a greenfield, so it was a security-first company from the ground up. Having it built into the culture, having it part of leadership's mission to have a secure, compliant company certainly makes it a lot easier to do what we've done. And what I'd like to do now is introduce Eric Ellis, who's going to take you through some of the complexities that we've experienced with this extreme security in our environment and the network segmentation, where we've run into a bunch of challenges, and how we're going to overcome that with the AWS Transient Gateway Firewall and the Palo Alto Networks Cloud Next Generation Firewall.
Thank you, Jesse. All right. Where I'd like to start is just to go in to where we started at Avalon with our strategy. As Jesse just mentioned, we start with a security-first mentality with everything we do. We were born in the cloud, so we started 100% in the cloud day one. As a startup, AWS gave us the flexibility and enterprise scalability for our startup. 2015, and what I want to do is I want to just walk you through over the years where we started and where we are today with our overall strategy. 2015, we started with one organizational unit and 4 VPCs, 4 firewalls. And the reason we did that was because of the hyper-segmented environment that we have. So each environment required us to put a firewall over each VPC. And so as you can see, moving on to 2017, as the company grows, so does our infrastructure. And the funny thing about it is that we have hyper growth, and each one of our customers is almost like landing a whale. And so when we look out after 2017, we come up to today and we start to look at how fast we're growing and the need to scale. And the question became, how do you scale from a small business that has a hyper-segmented environment with multiple firewalls? It's grown to 8 right now, and we start to think about our strategy for growth for the overall company as we start to gain customers on the West Coast. So when we look out to 2023, we start asking ourselves, what does that strategy look like before we get there, right? Where do we have to be in 2023? And I'd like to read this. Avalon's growth strategy to expand into multiple regions was hindered due to the rising costs of resources, the ability to scale securely, and management of existing and new infrastructure. And I'd like to go to the ability to scale securely. What that means to me is not that we can't scale securely in AWS, but we can't scale securely and keep our costs down, our human manpower down, and move across multiple regions in a single fashion without really tipping over our resources. And so what I like to do to kind of show you an example of what we're facing at Avalon and why we started to look at the cloud NGFW is welcome to my world. And this is a depiction of multiple VPCs segmented by our different environments. And then within those environments, we have segments by subnets, public and private, inside of each one of the VPCs. And if you look right on the center in the top, I know it's hard to see, but we had to just kind of show you a picture of what we're working with right now. In the center there, each one of those VPCs has a firewall. And so what that requires is constant monitoring and resources on each one of those firewalls. And so our strategy had to answer the question, how do we reduce the amount of firewalls, increase the security, and increase our ability to monitor from a single pane of glass? How can we get that done? And so that takes us into our requirements. We need best-in-class security and a cloud-native ease of use. And these are really self-explanatory, but the layer 7 firewall controls, the real-time updates, the ML-powered threat prevention to protect against zero-day. I need a firewall to get smart. I need that firewall to take over some of the responsibilities that my team now has to reduce the amount of workload that's on them throughout the day. So, cloud native ease of use, zero maintenance with no infrastructure. I like that. Built-in scalability and resiliency. Integration with other AWS services for automation of end-to-end workflows. Love it. Here's a single pane of glass. That's what I need. And that's what the Palo Alto Cloud NGFW gives us. A single pane of glass. So now all of a sudden I'm thinking to myself, I got a single pane of glass. What that means is all of my firewalls now go away, and I can monitor all my traffic at one place. Not only can I monitor all my traffic from one place, now all of a sudden I can integrate infrastructure as code. I can spread my firewall rules, and I can actually run that code to update as many NAT gateways and Cloud NGFWs as I need. Well, in this case, I'm going to be running two. So I can run that code, update my firewalls on both coasts almost simultaneously with the availability of being able to write that code in there. The Cloud NGFW, cloud native ease of use. Spoke about that before. Easy setup, zero maintenance, scalable policy management, automated NGFW provisioning. The automation in this is huge. And the fact that I got one single pane of glass, and my cost is low, but as my traffic increases, as the demand increases, now the firewall system, that's when it kicks in. And the Cloud NGFW automatically adjusts the amount of power I need to my workloads, then reduces. So giving me just what I need, just This is what it looks like now, today. So all of a sudden, you see where we use the NIs into our VPCs. And in the center, you can see our Cloud NGFW setup with our transit gateway. I kind of blew it up in that top left-hand corner so you could actually see where we can go in, we can use the Palo Alto third-party pane of glass, or we can go in and use the Firewall Manager inside of AWS. This also integrates into other AWS services. But this right here is the beginning of what our overall strategy looks like, right? Now we got that one pane of glass. Now we're able to funnel this traffic through here. Not only that, because we're in the healthcare environment, we have what's called PHI. And that PHI is personal health information, and we have non-PHI, right? So we have to segment that traffic. So if you notice in the top left-hand corner at the top, I got a little subnet up there. And that little subnet's showing you that that's non-PHI information, and I have it separated and segmented to my PHI information, which is below it, right? And so now I can take the VPC you see on the left, US East PHI environment, and now I can securely pipe that through one subnet and securely pipe the other information out the other subnet, the non-PHI subnet. This is Avalon's cloud, NGFW network strategy realized. And what this is depicting here is a strategy for East to West Coast. So we looked at it and said, okay, now we can view our network and we can view our security and our firewall system through one pane of glass. Now, not only that, my whole team can now go in and analyze traffic and data from the firewall systems. So I don't have to have a network engineer to log into a firewall or to give these guys access to a firewall. They can log right into AWS, go right into CloudWatch, take a look at the information they need to look at and review it, and they can come back if they have questions for us or whatever the case is. But the information is available to the entire operations team. And in this strategy right here, what happens is now that we have two gateways, one on the East Coast, one on the West, as we start to grow and we get customers such as like out in Hawaii, what happens is we get to cut the latency down for our customers out in Hawaii, as well as keep the latency down for our customers on the East Coast. Now, at the same time, we can view this through one pane of glass. And then, oh, by the way, East Coast goes down. We have it set up so that we can swing Route 53 and swing that traffic out to the West Coast. So we actually use the regions as an HA model, just like the availability zones. So Avalon's outcome with NGFW, it reduces Amazon, EC2, AWS networking and firewall licensing costs. It reduces engineering resources, load, and staffing needs. It reduces complexity of mapping multiple firewalls. You saw my world. It condenses 8 firewalls to one HA scalable system per region. Palo Alto Networks, Cloud NGFW, gives us the capability to secure multiple AWS regions, our multiple region strategy. AWS Firewall Manager and Palo Alto Network Cloud NGFW delivers results. We're really happy with it. All right, so we're going to go into questions and answers and things of that nature. Jesse, you want to come up? Right. You have any questions?
Okay. All right. Well, guys, if you all have any questions for us, we'll hang out, and then we can answer anything that someone has. All right?